Okay, we've reached the next phase. The very first thing we're always supposed to try to do when we are trying to evaluate a limit is plug in. We always show that we plugged in. For example, when I take 5 and plug in here, I get 10/15, that's 2/3. 2/3 minus 2/3 is 0, so I say the top is getting close to 0. Try to avoid saying equals 0 because I don't want to actually say something is equal to 0 over 0. When I plug in a 5 on the bottom, I get 25 minus 25 then, and that's also getting close to 0. Now in the past example, we started factoring, but oh boy, that fraction on the top is such a mess, I want to get rid of it. Now, if this is an algebra class and they say simplify, you'd probably get a common denominator on the top, and then you'd add the two fractions. We don't want to do that. That's too long. What we always want to do is find the smallest common denominator of all the little fractions. And in this particular case, that's just 15. So all I'm going to do is I'm going to multiply the whole top by 15 and the whole bottom by 15. Now, the idea is to fix the top and not ruin the bottom. So I don't multiply that 15 through in the bottom, I just write 15 times the bottom. Now when I multiply the 15 times the top, the 15 goes away here, I get 2x. 2/3 of 15 is 10, so I at least get something that looks a lot nicer. I'm going to try to plug in. When I plug in 5, I get 10 minus 10, that's 0. When I plug in 5, yeah, I still get 0. Now, here's the thing. We know that if we plug in 5 and get 0, that x minus 5 has to be a factor. So when I pull x minus 5 out here, I have a 2. You can see that x minus 5 pulls out here, leaving an x. So I have my x minus 5 on top, my x minus 5 on the bottom. They cancel. And what happens when we cancel? We are looking for the height of the hole. When we cancel, it just fills in the hole and makes a dot. And we can find the height of the dot of the new function just by plugging in. And then we get 2/75, and we're all done.